The design objectives of this project were to build a structure using beams, trusses, and frames. We decided to build a water slide out of balsa wood, wooden dowels. There were 42 members used in the structure, connected together using wood glue and super glue. The slide itself, on a 1:32 scale. This meant in real life the slide would be 4 stories tall, 12 feet wide, and 66 feet from end to end.
The structure was obviously put in SAP, and the proper material was defined in materials. Because we're analyzing a truss, all the moments need to be released because there's no moment in a truss. In order to calculate the deformation in SAP, the loadings needed to be calculated. Because of the truss, we know that all the loadings happen at these points. And so these points would bear the load that's on the section around them. So for this point, it would bear this section. This point, it would bear this section. And so that needed to be calculated. In order to get the data up for deformation, we simply exported it to an Excel file. Basically.
Over. To start out, Dan's going to measure the members out on the towel, and then he's going to cut them with a PVC cutter. I don't think those are on. Those seem a little big.
So right now we're laying out the members of our slide. We're laying them down on newspaper. We're going to glue them together at the joints, and then we're going to apply masking tape so the joints will hold long enough for the wood to dry. We left the glue to set overnight, and when we checked these out in the morning, we had some pretty sturdy truss members. Check that out.
The slide was hooked up to a dial gauge to measure the deflection. A 3-pound piece of steel was put on to represent the distributed load of the water going down, and a 7-pound point load was put on to represent a person. And the combined loading together will give us the maximum deflection.
SAP predicted a maximum deflection of about 23 thousandths of an inch. However, the maximum deflection we observed was only about 16 thousandths of an inch. This means that the structure was much stronger than what SAP predicted. The added strength was likely due to the fact that the SAP model was designed with pin joints, while the wood glue on our actual model acted more like a fixed joint.